Hi everyone, welcome back again to Mathematics for Engineering 3, uh, International Programs Kazakhstan University. Today we're going to continue from the previous video. It's going to be section 3.2 when we talked about the solution near an ordinary point x when x is not 0. In the previous video, we looked at the solutions in terms of power series, right? Near the ordinary point when x equals 0. But today we're gonna look at the case when x is not 0. It's still an ordinary point, but it is not 0. Okay, so it's the solution near or around an ordinary point which is not 0. Okay, so let's start. 3.2, the around an ordinary point a equals a. X equal a when a here is not 0. For example, the solution around x equals 2 or x equals 1. But don't forget, guys, these points, they need to be ordinary points. Okay, they need to be ordinary points. They are just not 0. Okay, so the solution can be obtained similarly to x equals to 0. Okay, it's the same as the previous section, but the trick or the difference is that we need to do substitution first. Okay, and the substitution you need to do is to substitute u with x minus a. Okay, for example, if you want to find the solution around x equals 2, you need to substitute u with x minus 2, and here is with u with x minus 1, and that is the substitutions we need to make. Okay, so that is the only trick. Okay, that's the only trick. So first you substitution u with x minus a, and if you want to know y prime is dy by dx, right? But from chain rule, you know that will be dy by du and du by dx. But guys, u is x minus a, so du by dx is dx minus a by dx, but a is a constant, right? So that would be just dx by dx, which is 1. Okay, so this guy, it is 1. So we have that is actually dy by du. Okay, so what you need to remember is that the y prime, which is dy by dx, is the same as dy by du. Okay, so first you substitute u with x minus a. dy by dx is the same as dy by du. Okay, and then y double prime would be d by dx, dy by dx, and then d by dx again, right? That is the definition of y double prime, right? And that would be d by dx, and dy by dx is actually the same as dy by du, right? From here, it's actually the same as dy by du. Okay, and then by chain rule, there will be d by du, dy by du, and then du by dx. Okay, but again, guys, du by dx is 1, so there will be d y by du. Okay, so what you need to remember here is actually dy by dx, right? So what you need to know is that first we substitute u with x minus a. After that, you know that dy by dx is the same as dy by du. Moreover, the second derivative of y with respect to x is the same as the second derivative of y with respect to u. Okay, that will be 3 things you need to do, and the rest is the same as the previous video. Okay, so let's look at an example. Here you are asked to find the solution around x equals 2. See, right now it's x equals 2 and 2 is not 0. It's different, see, it's not x equals 0 anymore. Okay, of this equation. Okay, so first we are still looking at ordinary points, right? So first we need to check whether or not x equals 2 is an ordinary point. Is it? But we know that right now b2x is 1, right? It's just the coefficient of y double prime, right? So b2x is 1. It means that b2 of 2, that is 1 as well, which is not 0. Which means that x equals 2 is an ordinary point. Okay, so the first thing we do is to let u be x minus 2. That is the first thing, which is to do substitution. Okay, and then y prime is actually dy by du. Dy y prime is actually dy by dx, but again dy by dx is the same as dy by du as we wrote here, so I don't care. Y prime is dy by du, dy by dx doesn't really matter. Okay, so because we do substitution with we do substitution and we have a variable u, so I'm going to use dy by du. And similarly y double prime would be dy by du. Okay, the second derivative. Okay, so we can rewrite this equation. We can rewrite this star equation to, what is it, y double prime would be dy by du, right? Or to make it even easier, I can write down just y double prime, because y double prime here is d by dx, right? But y double prime here is d by du, but it doesn't really matter, they are the same. Okay, plus x minus 2, that is u. Okay, and then y prime, that is the same, y prime, because dy by dx is the same as dy by du, minus 4u, and then y equals 0. Okay, and this is the question around u equals 0. Okay, it will be the solution around, I forgot the n, around u equals 0. And here it back to 3.1, right? Right now our problem is find the solution of this equation around u equals 0, and u equals 0 is an ordinary point. Okay, because if x is 2 is an ordinary point, u equals 0 is automatically an ordinary point as well. Okay, so after this we can write down, it's the same, right now it's the same as the previous section. So we know that the solution y is summation n from 0 to infinity an, but it's not x to the n, it would be u to the n. Okay, this is a different, right now our variable is u, it's not x anymore, so it's an u to the n, and then we find y prime, y double prime, right? And then we do substitution, and then we rearrange the terms, and then we change the exponents, right? We change the summation. After that we set all the coefficients to 0. Okay, and after that we get some conditions and we get the recurrence relation, and then we can find all the a1, a2, a3 until all the a's until whatever we want, and then we get the solution. See, so if you can follow what I'm speaking, you already know the steps. If you don't, you need to go back to the previous video and try to remember all the steps because they are always the same. You just need to follow the same steps over and over. So it would be better if you can remember the steps. Okay, so we have that y prime would be sum n from 0 to infinity n a n u to the n minus 1, and y double prime would be sum n from 0 to infinity n minus 1 a n u to the n minus 2. After that, we put all of these into this equation, right? So what we have would be summation n from 0 to infinity n minus 1 a n u to the n minus 2. Okay, and then plus u my x minus 2, that is u, right? Because we substitute u with x minus 2. So this would be u squared. And then y prime, that will be u squared summation n from 0 to infinity n a n u to the n minus 1. And then minus 4 and x minus 2, that will be u, and y would be summation n from 0 to infinity a n u to the n equals 0. Okay, after that, as you can see, before we rearrange the exponents, let me simplify the equation a little bit. So here I would have summation n from 0 to infinity n minus 1 a n u to the n minus 2, and then plus summation n from 0 to infinity a n u to the n plus 1. Guys, here it is u squared and u to the n minus 1. So I multiply u squared to u to the n minus 1. So I get u to the n plus 1. Okay, and the next term would be minus summation n from 0 to infinity for a n u to the n plus 1 equals 0. And then guys, as you can see, this is u to the n plus 1, this is u to the n plus 1, so I'll group them together. Okay, so what I have would be summation n from 0 to infinity n minus 1 a n u to the n minus 2 plus summation n from 0 to infinity n minus 4 a n u to the n plus 1. Okay, that will be n minus 4 a n u to the n plus 1 equals 0. After that, we need to rearrange the exponents, right? Because the exponents here is x minus 2, x plus 1. So we need to change x plus 2 to x minus 2. Sorry, we need to change x plus 1 to x minus 2. And that can be done by, if you notice, from 0 to infinity, n minus 4, and then a n u to the n plus 1. We can change it to summation n from 3. Okay, we need to start from 3 because we're gonna substitute n with n minus 3. You'll see in a minute. Okay, so if I begin from 3, n here, n minus 4, that will be n minus 3 minus 4. A n minus 3. Okay, we need to change n to n minus 3. And u to the n minus 3 plus 1 equals 0. Okay, and that is actually summation n from 3 to infinity n minus 7 a n minus 3 u to the n minus 2. See, and there's no equal sign here, sorry. Okay, so I can substitute this back into this. Okay, so what I have would be, what is it? I would have, one second, uh, summation n from 0 to infinity, n minus 1 a n u to the n minus 2 plus summation n from 3 to infinity n minus 7 a n minus 3 u to the n minus 2 equals 0. Okay, is that good? And next, right now we have the same exponents. What we have to deal with is the summation sign here. Okay, is this one is from 0 to infinity, here is from 3 to infinity, so we need to somehow split this. Okay, from n equals 0, n equals 1, n equals 2, and then summation n from 3 to infinity. Okay, we need to take them to the same summation. Okay, let me get the new page. So from here we have that it is if n is 0, we would get 0 a0 u to the minus 2 plus when n is 1 we would get 0 a1 u to the minus 1. So when a is 2 we would get plus 2 a2 u to the 0, and when it's 3 we're gonna take the summation from 3 to infinity, n minus 1 a n u to the n minus 2, and the other one would be summation n from 3 to infinity n minus 7 a n minus 3 u to the n minus 2. Okay, after that I just rewrite all the thing. So here this is what I would have: 2a2 u to the 0 plus summation n from 3 to infinity. Okay, and then we get n minus 1 a n plus n minus 7 a n minus 3 u to the n minus 2 equals 0. Okay, and after that we use the property that the coefficients of x, in this case is the coefficients of u, are 0. Okay, so we can take all of these to 0. Okay, so first here we have that 0a0 is 0, 0a1 is 0, 2a2 is 0, right? And 0a0 is 0. It means that here it would just mean that a0 and a1 are any constants, right? But 2a2 is 0. It means that a2 is 0. Guys, they are different. Okay, they are different, guys. Don't get confused. 0a0 is 0. This one. It means that a0 can be anything. For example, if a0 is 10, 10 times 0 is still 0. See, it means that a0 can be anything. But here 2 times a2 is 0. It means that a2 needs to be 0. Okay, so a0 and a1 can be any constants. A2 is 0, and here we get the recurrence relation, right? Which means that we have that an is, okay, I move this to the right hand side, right? Because this whole thing is 0, so I move to the right hand side. I would have minus n minus 7 a n minus 3 divided by n, n minus 3 divided by n minus 1. Okay, and this is when n is greater or equal to 3. Okay, because we know a0, a1, and a2 already. Good. Good. And then we need to write down A1, A0, A1, A2, A3, A4, A5, blah, 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 right? If they don't say anything, guys, in the exam, if they don't say anything, you don't need to write down at least 4 terms for A0 and A1. Okay, for these constants, you need to write down at least 4 terms. But just in case they have additional instruction, if they have additional instruction, for example, this question, they might say that write down the solution until A8, for example. If they ask you to write down the solution until A8, you need to write down the solution until A8. It doesn't matter how many terms are there. You need to write down the solution until A8. So in the exam, just watch out, okay? If they don't say anything, write down at least 4 terms for each A0 and A1. If they say write down the solution until A8, A10, A12, just do what they ask. Okay, so in this case, I'll just assume that they ask us to write down the solution until A8. Okay, so we'll begin with A3. A3 is, you need to use this condition, right? So A3, that would be minus 3 minus 7, that is minus 4. And then A0 divided by 3 and 3 minus 1, 3 times 2. Okay, that would be 2/3 A0. Okay, that would be A3. Oops. A3 is 2/3 A0. Okay, after that, we need to write down A4. A4, let me write it down here. A4 would be, what is it? It would be minus, and then 4, that would be minus 3. And then A1 divided by 4 times 3, and that cancel out. So you get A1 divided by 4. Okay, you get A1 divided by 4. And then A5, that would be minus, and then 5 minus 7, that is minus 2. And then you get A2 divided by 5 times 4, and that cancel out. So you get 1/10 A2, but A2 is actually 0, so it's 0. Okay, and A6 would be minus 1. You substitute n here with 6, right? So you get minus of minus 1, A3 divided by 6 times 5, and that would be 1/30 A3, but A3 is actually 2/3 A0, so that would be 2/90 A0. Okay, that would be 2/90 A0. Okay, the next one would be A7, and A7 would be, what is it? What is A7? Let me split it so that we see it clearly and we don't get confused. Okay, so A7 would be minus 0 A4 divided by 7 times 6, and that is 0. Okay, and A8 would be minus 8 minus 7 divided by 8 times x minus 1, A5, but A5 is 0 here. A5 is 0. It means that this guy is 0 as well. Okay, and then we have 8, 9, 8, 10, 8, 11, blah blah blah. Okay, so if the question here doesn't say anything, like this, you need to make sure that you get at least 4 terms for A0 and 4 terms for A1. Okay, but if it says that you just need to write down the solution until A8, you just stop here because you already get A8, right? So now I'm gonna write down the solution. The solution y would be summation n from 0 to infinity a n u to the n. Guys, don't forget, right now our solution is y equals summation n from 0 to infinity a n u to the n. And that would be, what is it? A0 is, what is it? A0 is just A0, right? U to the 0, which is 1. Plus A1 U to the 1. Plus A2, but A2 is 0. Okay? Plus A3, A3 that is 2/3 A0 U cubed. Okay? Plus A4 is 1/4 A1 U fourth. Okay, and then A5 that would be 0. A6 that would be 290 U to the 6, and then A7 is 0 as well, and then plus blah blah blah. Okay, in this case we would have what is it, we grouped the A0 together, right? So we have 1 2 oops, I forget A0 here. Okay, it's 2/90 A0. Okay, so we have A0 here as well. So here we have 3 terms. Okay, if the question doesn't say it until A8, we need 1 more term, right? Because we need at least 4 terms. But if they say find the solution until A8, so we can just stop here. So we have A0, 1 plus 2/3 U cubed plus 2 to the 90 U6 plus blah blah blah. And then plus what's next? U A1 U plus 1/4 A1, right? Plus blah 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 blah. Oops, plus 1/4 A1 U to the 4 plus blah blah blah. Okay, but guys, if you look here, you need to write down A1 when you have a, okay, let me take some note here. Okay, let me take some note here. You need to write down A1 when you write A4, right? Because if you have A4, they would be A4 minus 3, which is A1. Okay, so if you write A4, it would be in terms of A1. Make sense? And the next A would be A7. Why? Because if you write down A7, that would be, you would need to write and something and A4, right? And that would be something and A1. Okay, because A4 can be written in terms of A1. A7 can be written in terms of A4 using this recurrence relation. Guys, again, you will have A1. You have A1 here, the term A1. If and only if you have A4. Why? Because if n is 4, it's going to be 4 minus 3. So A4 can be written in terms of A1, as you can see here. Okay? And you will have A1 again when you have A7, right? Because A7 is something and then A4, which is something and then A1, right? You will have A1 again when you have A7. And you will have A1 again when you have A10, right? Because A10, that would be something A7, which is something A4, which is something a1. Okay, but guys, if a7 is already 0, a7 is already 0, what does that mean? It means that a10 is going to be 0 as well. Okay, because a10 can be written in terms of a7, and then a13 is going to be 0, a16 is going to be 0 as well, right? And a1, they can appear if you have these terms, but these terms can never happen again because a7 is already 0. Okay, so here we need to erase this dot dot dot. Why? Again, why? Because we never have a1 again, not ever. Again, guys, I know this is a little bit confusing. Here you will have a1, the a1 term, you know, when n is 1, right? Definitely you have a1. When n is 4, you definitely have a1 again, right? Because when n is 4, here that will be 4 minus 3, so you get a1 again. See, when n is 7, you get 7, you get a4, and a4 you get a1 again. Okay, when you have 10, you have 10, you have a7, you have a7, you have a4, and then you have a1 again. And then 13, you have a13, you have a10, which is a7, which is a4, and then you have a1 again. But guys, because a7 is already 0, so when you write down a10 in terms of something times a7, a10 is going to be 0 as well. And if a10 is 0, a13 is 0, a16 is 0, a19 is 0, it means that a1 will never appear again. Because, you know, because this a7 is already 0. Okay, so they disappear forever. It means that you don't need plus blah blah blah. Okay, you shouldn't write plus blah blah blah. And this is the, oops, let me delete this just to, you know, avoid the confusion. Okay, and you may stop here and say, oh, this is the solution, and you won't get the full mark because the question is in terms of x. So if you want to answer, you need to answer in terms of x as well, but you know that u is x minus 2. Okay, so in the end, you need to answer this question as 1 plus 2/3 x minus 2 cubed plus 2 minus over 90 x minus 2 to the 6 plus blah 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 plus a1 x minus 2 plus 1/4 1/4 x minus 2 to the 4. Sorry, there's no a1 here anymore. Okay, it's already pulled out. Okay, and that would be the solution. Okay, so let me sum it up. Guys, this question, to find the solution about or around x equals 2, is the same as what we did in the previous video. Okay, but we need to first, the same thing, we need to check whether or not x equals 2 is an ordinary point, and it turns out that it is. After that, we need to do substitution, u equals x minus 2, and then we know that, you know, y double prime is still y double prime because dy by dx is still the same as dy by du. Okay, so here we can still write y double prime, y prime, and y, so we keep them the same. Okay, and then we change this x minus 2 to u and x minus 2 here to u as well. Okay, and then the problem here, change to this equation around x u equals 0, and that is exactly the same as in the previous section. Okay, so when x is a, which is not 0, these two lines are an extra steps. Okay, they are extra steps. The rest is the same as in the previous section. Okay, so guys, in this video we looked at the solutions when we want to find the solution around an ordinary point which is not 0. The trick is that we substitute u with we substitute x minus a with u. Okay, we try to write down the equation in terms of u. And the trick, there are three things. First, let u equals x minus a. Second, you need to know that dy by dx is the same as dy by du. Okay. Third, the second derivative of y with respect to x is the same as the second derivative of y with respect to u. Okay, and after that the problem becomes differential equations in terms of u around u equals 0, which is an ordinary point, and then it's back to the previous section. Okay, guys, try to do exercises. Okay, I uploaded the exercises to the post. Okay, to the in the live group. So if you have time, you should have time. Okay, so you practice, do exercises. Guys, these, they look very messy, they look very, they look very hard, but they are actually very easy. Therefore they follow the same step every single time. So you need to do many exercises, and then you eventually remember the steps, and then it's going to be really easy for you guys. The exam is coming, okay, in the next week. So try to do exercises, try to be more productive, guys. We're going to survive this together. And if you have any questions, just contact me, just let me know, we can talk about that. Okay, so see you in the next video, guys. Bye bye, take care.